So another concept that we need to talk about are the properties of real numbers. And the first property we will talk about will be the commutative property. And the commutative property always involves two numbers. So it may be in a bigger problem that has lots of different numbers, but if the focus of the change or what's happened is on two numbers exclusively, it's the commutative property. In terms of addition, what this might look like is something like 2 plus 3 is equal to 3 plus 2. Or generally speaking, A plus B equals B plus A. Right, if you add any two numbers, the order doesn't matter. Now the same is true for multiplication. If we're multiplying two numbers, the order in which you multiply them does not really matter. We know that 4 times 5 is the same as 5 times 4. The order isn't important. Or generally speaking, A times B will give you the same result as B times A. The order in which you add or multiply two numbers does not affect the outcome as a way to talk about the commutative property. The next property is the associative property. And the associative property is very similar to commutative. It happens to involve three or more numbers, and I'm not really sure why there's this distinction. In terms of addition, we know by order of operations that if we saw something like 2 plus 3 plus 4, grouping symbols, the parentheses, indicate that we need to add 3 plus 4 together first, and then add 2 to that. But we will get the same result if we grouped it this way and added 2 plus 3 together first, and then added 4. Right, the order in which you add three or more numbers does not affect the outcome either. Or generally speaking, A plus B plus C is the same as A plus B plus C, where the grouping symbols describe the order. Multiplication is going to be very similar. 5 times 6 times 7 is the same as 5 times 6 and then times 7. They're both 210, or generally some number A times the product of B and C is the same as the product of A and B, and that being multiplied by C. Or in other words, the order in which you add or multiply three or more numbers will not affect the outcome, but the order won't impact anything. The third property is the identity property. This has to do in some way, shape, or form with a number staying itself even if you do something to it. In terms of addition, we know that if we take a number like 3 and add 0 to it, we still get 3. Right? So adding 0 to something does not change its identity, or any number plus 0. Same number. Multiplication, to get the original number, if we started with 4, if we multiplied that number by 1, we get 4 again. We get the same number, the same identity. The identity is not being changed. Or any number times 1 equals itself. So identity property has to do with how you can add or multiply and not actually have any kind of change. It's just an identity. The inverse properties, in terms of addition, this is sometimes called the property of opposites. If you take a number like 2 and add its opposite, 2 plus the opposite of 2, which is sometimes described as negative 2, equals 0. Or generally speaking, if you have any number and you add its opposite to it, you will always get 0. A number and its opposite always adds to 0. Now, in terms of multiplication, the inverse property has to do with reciprocal. If you take a number like 3 and multiply it by its reciprocal, 1/3, the number 1. By definition, this is why they are reciprocals. Reciprocals are two numbers whose product equals 1. Or generally speaking, take some number a and multiply it by 1 over a, and you will always get 1. The final property we need to focus on today is the distributive property. And the way to talk about this in words is multiplication over addition and or subtraction. So, for example, if we have 2 times 7 plus 9, order of operations would say do what's in the parentheses first and then multiply 2. But by the distributive property, we can distribute the 2 to both 7 and 9. Do the multiplication first. In this case, we would end up with 14 plus 18, which when you add that is equal to 32. And that's the same thing we would have gotten. How do we follow order of operations? It doesn't matter how many numbers are here. We could have 3 times 4 plus 5 minus 7. It doesn't matter the order. I'm still distributing 3 in this case to all three numbers. You get 12 plus 15 minus 21, just 27 minus 21, or 6. I could see it in a different order. It could be something like 6 minus 4 times, distribute in this direction, 12 minus 8, which is 4. It's all multiplication over addition and subtraction. It's one property that allows you to avoid and not follow order of operations. So that would be our 5 properties: distributive property, inverse property, identity properties,